Example, for a coil having an area of 8 centimeters square and 50 turns. This is actually 50 turns lies perpendicularly to a magnetic field of 0.2 Tesla. So if the magnetic flux density is steadily reduced to 0 taking 0.5 seconds, determine the initial magnetic flux linkage and the induced EMF. Okay, so given is the area, which is equal to 8 centimeters square, and the number of turns is 50. Also, it gives us the initial magnetic field, which is equal to 0.2 Tesla. Okay, and then it is reduced steadily to 0, and it takes about 0.5 seconds. So we have to determine the initial magnetic flux linkage. Wait, before that, let me draw the situation. So this is the magnetic flux, and then the plane lies perpendicularly. So it lies perpendicularly to the magnetic field. So the vector area is this one. So the angle is 0 degree. Okay, so remember the magnetic flux linkage is calculated using this equation lah. Okay, so also we know that the magnetic flux is equal to, since there is n, we have times it with n lah, cos theta. Okay, so this is for initial lah. So just substitute that into here. So n square, we have no, we cannot double that, sorry. So we know that this is the equation for magnetic flux, so just substitute into here. Okay, so we'll then obtain the initial magnetic flux linkage to be equal to 8 times 10 negative 3 Weber lah. Okay, and then the induced EMF, I'm just gonna do it here. So the induced EMF is given by this equation. So apa yang changing? Wait, let me just write it. I know. Okay, so what is changing? What is changing is the magnetic flux. Magnetic flux density is reduced to 0. Okay, so from here they reduced to 0. So what is changing is the magnetic flux lah. Okay, so we'll then use this equation lah, dB over dt, where dB is equal to B final minus B initial. Okay, boleh ya? So dari sini we'll then get negative NA cos theta BF minus BI over dt. Okay, so we'll then get 1.6 times 10 negative 2 volt as the induced EMF lah. Okay, that is on example number 4.